Docker, kind of doing it on a small scale. Now you're doing it system-wide stuff. So very, very cool. Very, very awesome. While we have a moment, Docker is unbelievably easy to play around with. If you want to try it, play around with it. Great thing is it runs so many different environments, not just bare metal. So there's a phenomenal little ISO called Boot to Docker. It is a walking 47 megs. All you have to have is build up a tiny core Linux. You can actually download that, run it in VMware, VirtualBox, whatever. You've got a full Docker environment. Really, really cool. AWS, any AWS fans here? Amazon Web Services? Sorry. They now have a more streamlined Docker ecosystem that they have. Any DigitalOcean fans? All right, okay. So DigitalOcean is one of my big fan companies. Because they started using Docker in their droplets and VPSs in September. So they actually had an environment that you could go and play around with Docker very, very early on. And they have done amazing for you. You can go to DigitalOcean, and it's like $5 a month for VPS, which is extremely reasonable. That's the maximum. You can't pay per hour. And they actually have a Docker-specific build. It's built on Ubuntu. I think they've actually converted over to Docker 14.4 specific build. But if you want to play around with it, I highly recommend that. Mainly because the guys at DigitalOcean stepped up big time in this event and is giving everybody that's here a $25 credit for their service. So I've got a bunch of cards that have promo codes on them, and be sure to come up and get them. This is 5 months of free service. Or if you're like me, it's like 2 weeks. That's not a bunch of DMs. But it's really cool. I encourage you guys to go check these guys out. They're really, really awesome. They've got, obviously, Ubuntu, CentOS, all this different stuff. You can go play around with it. Really, really cheap VPS service. Really, really reliable. And also API. If you like to do like command line deployments and stuff. It's really, really cool, top-notch guys. So be sure to get one of these cards. If any of you guys are on Twitter or Facebook or anything like that, please give them a shout-out and tell them thank you, because most of the time when they do promotional code, it's like a $10 promotion. Icon, this past whenever, February, yeah, they did $10. So give, like, when it dropped in my email box, it had $25, I was jumping. Yeah, I saw what they did that. I was like, well, I'm not that good. It was only for your time. Yeah. So if you already do have an account, have a second account. Because that's what I did for a long time. They have officially started getting my money. Give me just a second to get back up and running. Well, actually, I'll let you know. All right, so the presentation, we're going to go back to it. It is a document. So I'll get into the syntax a little bit, but basically what I'm going to do is I've got an image of Docker Greenville, and it's issuing Docker, and I want it to run. And the -D is to run it in detach mode, meaning it just starts it and then backs out, and that's my image. So we're going to crank this one up, and it's done. It's up and running. So let me actually do a Docker spec. It's actually exactly this. And we'll go into this a little bit more. There's a ton of information. This is basically a snapshot or a glimpse of everything that's going on in this. I think it's really, really useful. So let me jump over and actually open up the presentation. We're almost to the demo. That's my favorite part. Any questions? Yes.
If you were deploying this, with Docker authority to already set up, but deployment applications are already set up.
That I do not know. I have exactly this much JBoss experience, so the integration.
So you don't need to.
All right, so say the question again.
So if you're deploying multiple PHP sites, then we have running back.
Yeah.
Will it run multiple copies of that, or will it
It does run multiple instances. Every container gets its own process. So while you're sharing the libraries and things like that, you actually have its own process. So if you're running, if you're doing something stupid like I tried to do, they spin up an entire /16 WordPress instances. It will crash your system, I promise you. There's literally 65,000 whatever instances of Apache, PHP, and everything else running. And so everything is completely out. Whatever it takes to run that application in that container, every single instance of that container has all those necessary components and all those necessary processes. So let's pull this back up. So yeah, let me send you this right quick. But yeah, so this actual presentation is done in your build.js, but actually you built it in a Docker container, and it's just using the favorite little command in all the world, Python-m simple HTTP server. Yes, yeah, HTTP server on the fly, and so that's all it's doing. It's that. All right, okay, so we're using FileSystems. So we'll run through this real quick. So you have your base image, okay? And Docker is based off of image. And that can be Debbie, that can be Simplex, that can be Ubuntu, that can be BSides, that can be actually anything you actually create. And then you have all your references, layers and stuff. And so this is kind of like, let's say I have an Apache image. So I build that off of the base, and then I build my Apache stuff on top of that. So that's a reference layer that I can then use for something else later. And then, and so you've got several different nodes. And the container is the only writable part of the entire image, and it sits right on top. So while it may look like this is your entire container, in fact, it's only just that top part, because all that other stuff just exists in a read-only image. So each layer of the file system is mounted on top of prior layers. This is the union file system. It's a layered approach. The first layer is always the base image. The current base includes Debian, Ubuntu, BSides, Fedora, CentOS.
So if you've got a customized container for an app, and you have to know what containers it's using in order to properly transport that around?
No. No. We'll get into that in a minute. Yes.
And the base layer is on top of that. Bare metal content.
Yes. Yes. So the base image, this here is basically the base for your container. It's completely isolated from what your actual host environment is. And that's really, really important because I'm an Ubuntu guy, and I can run CentOS containers on my Ubuntu. Or if you're Red Hat, you can here and run Debian and Ubuntu all at the same time. Because it's just shipping the kernel. The actual host operating system doesn't. Because it's actually got direct links into the kernel through namespaces, C groups, and the union file system that actually allows us to work really, really smoothly. So we're hardware agnostic, but for the most part, we're operating agnostic. That's what makes this thing really beautiful. Bare metal VM doesn't matter. Doesn't matter if you're comfortable. Like this is what I like. If you're a Fedora guy, you're using a hardcore Fedora, and you come into an environment that's like, hey, we're dead. Ooh, that kind of stinks. but all you're doing is developing an application. You can develop in a dead container, and you're very, very much the large majority of it. So you stay with everything you're comfortable with, what you know, and you isolate to just what the specifics are. So each read-only layer is called an image, and it's just a collection of files and folders. And the images get stacked on top of each other. So you start off with a base image, you make a change, you add some services, applications, or whatever, you commit that, well, that's a new image. You create a new image. But what it really is you have the base, and you have the modifications. And so then I use that original, or that new image that I have, and then I use that to build my next application. So a lot of use cases, like people will start specific like web and stuff. They start off with a base container, then they add their Apache and PHP and stuff, and then they start. So then they all of a sudden they wrap that up in the image, and now this is where we want to start. So you don't have to repeat these processes every single time we want to do something. So if you have a base environment, if you start at at ground zero every single time, create that once. Everybody in your team uses it, and you're the same starting point every single time. All of a sudden something changes, we need to modify our starting point. Cool. Take that image, build it, top of it, commit it. You now have a new version of your previous. And you have both of them available to you. That's the one thing, or one of the main things that's really nice is just because I make changes to an image and I build a new image off that, I can still go back to the old one. So if something doesn't work here on that stuff, go back. Really, really beneficial. The top layer is the only modifiable layer, and it is from the container. So when we're talking about containers, we're actually talking about the top level where we are actually interacting, we're actually doing what our application is actually doing. Anything we've done after we start using the word image, that's the container. All right, so as you've seen already a little bit, let's figure this out. Seems like a really big version track. All right, here we go. Can everybody see that? A unit with one wall. Here. We don't see that now? Real quick. All right, so the first thing you're going to do is there's instructions online at docker.io to actually get Docker up and running in your system. If you're a go-to guy and you switch to 14.04, it's as simple as sudo apt-get install docker.io. For everything else, it's a little more difficult. You have to actually add the source list, entries, and stuff like that. But it's pretty painless. The current version of Docker is 0.11.1. 0.11 was the first release candidate for 1.0, which would be the production ready. They do say that Docker is not production ready, and everybody scoffs at that and keep going on in production. there are literally thousands and thousands of applications and services already running on it in production with the stakeholders. It just works. And they just make it better and better and better and better. So I am expecting the 1.0 release probably in the next 12 weeks to the typical release of nature every 6 weeks. And so because this is the first time they've actually done an incremental like 0.11.1. So lots of changes. A little bit about the actual project itself was released in March 23rd, 2013 as an open source product. And right now they've got 426 contributors worldwide, over 8,000 commits, over 200,000 pull requests, and about 55% of the contributions and commits are outside the company Docker Greenville. So it's a really, really aggressive project in terms of the open source. Obviously, big companies such as Red Hat, DigitalOcean, AWS, IBM, they're all taking notice and they're actually pumping resources into Docker development and things like that. Docker plays really, really well with OpenStack. So yeah. So to start off, we'll just look at actually the Docker command. There's a lot of things that you can actually do. So we'll look at obviously from the bottom down. You've got different things top. Okay, I think people want to top. Look at the top. Okay. Each container, you can do this on a per container basis, so you can see those processes. But you don't have to be in the container, which is really, really nice. Tag is tagging an image for the repository, start, stop. Search for the image in the Docker index. The Docker index, index.docker.io, it is the global registry for the Docker index. It's kind of like GitHub for Docker. You can develop a container or an image, and then actually push it to the registry, and then everybody can go and download it. But you can also have your own private registry, like internally and stuff like that, if you're doing, closed development and stuff like that, but you don't want to public and stuff. But you can actually search that index for anything. You have save, which is nice because you can actually save the image to a car. Run, RMI, remove image, RM for remove one or more container, restart, just basic. Let's see, pull, which is a really important one. You use Docker pull and you give them an image, and it will pull it from the registry. Or if you've got a remote private registry, you can get that notification, and it'll pull that image as well. And this is one of the things that's nice. So I build a container, all right, cool, I've got something working. I then commit it, and when I commit it, it actually converts it to an image, which I can then publish to the registry, or whether it's Docker or myself, and then anybody that has access to that registry, they can go download the same image that I was working with, which is really, really nice. Inspect, really, really awesome low-level information on the container. Gives you like networking, host name, all this different stuff, ports, different things. The ports can get really interesting because obviously if you're running on a host environment, Docker has its own network. It uses its own bridge. So like in here we may be on like 192.168 or whatever. I'm actually on 172.17.0 w/. In this case, probably 24. So it has its own private networking, which you can then expose anything you need to the actual host machine. So like if you've got a bunch of like 480s and stuff, you can actually do that fairly easy. But instead of using that information, info, displays, system-wide information, import's really cool. If you've got a protocol of the existing file system, you can convert that to a document or container. So that's really, really handy. History, really awesome because you can see the entire history of the instance. So basically from the point that it was actually created, and every change. So if I go and use an image that when you guys created, which you built off of somebody else's image, you built off what they built off, I can see that entire image, which is really, really nice. Diff, you can inspect your changes. And so what it does is it basically looks at the image that it was built off of, and then goes, this is everything that's changed. Really, really handy. Copy, you can actually copy files and folders into or from containers. Obviously, knit, build from a Dockerfile. We're going to hit on Dockerfile here really quickly, and then attach. Attach is, so like with the detach mode that I ran my presentation, I can actually then attach to it. It's essentially like a pseudo SSH session. I'm now at the root prompt, and I can do whatever I want to, and I can exit out. The nice thing is the process tree is still running, so everything's up and good. I just just pop in and out of boxes, run these things in containers fairly easily. So let's clear this up. So Docker images. As you can see, I've got a fair amount. So I've got a couple of subnets. And what you notice is I've got 6.4, and I've got latest, and then I've got some UCLUG and Shipyard, and the Apache ones are always my favorite. And if you look, I've got precise, I've got latest, I've got 1204, 1310, Saucy, Wryen, 304, and 1304. So I have all these different actual versions of Ubuntu that I can build images off of. So let's say 1204 was my bread and butter as a developer or something. I can build it off 1204. I know it's going to work. It's going to be awesome. I don't have to use the latest. I don't have to identically choose and stuff like that. So let's actually we'll pull the Dockerfile dev. So what's going to happen is it's going to start pulling the output. And if you notice, really, you can't see it in its entirety. But this is actually doing parallel. Because remember, the image is just a bunch of layers. So it's actually just downloading those layers. And you can see a lot here. So you actually, instead of having to download this one chunk concurrently, you can actually, or singular, you can actually do all this in concurrency, which is really, really nice. Still takes a while because what it's actually doing is it's downloading kind of the entire Debian structure, so you'll see different versions of Debian, just the way you did it. We'll give just a minute to actually finish downloading. And then all I've done is send a request to Docker registry, pulled it down. It's like, hey, it doesn't exist. Let me pull it right quick. And so now this will be on my system. And from here, I can actually start building Debian-based application once it's downloaded. Yes, sir.
Say that all versions.
All of the ones that are in the actual Debian image tree from image. So it'd probably be like, you'd probably see like Wheezy and a couple of others, something like that. So let's actually see what it sees. Yeah, so I've got 6.0.9, Squeeze, Jesse, testing, SID, old stable. Yeah, it's 7.4. So it's given now obviously I can get rid of all of this. Now, what I could have done, if I wanted to, let's say Squeeze is the latest. We'll say Squeeze. I could have done Dockerfile, Debian, Squeeze, and given it that tag, which is what these are, and then it would have just downloaded that single image. So you kind of have this like weird situation, like all of these tags go to the parent, and so when you download the parent, you get all the tags with it. So let's start Docker Greenville. One thing, there are several command line options that you can use from time to time. Mostly 3 that you can use like all the time. The first one is going to be -I, which is going to be interactive. -T, which is going to give you a TTY in the actual shell. So it's really important. The other one would be -D for detach. So if you're not running I, you're typically running -D, one or the other. Debian, and we're just going to cache in select bins like that. And I'm going to show you. I'll let that sleep. Y'all can spit enough y'all videos. That fast. An entire Debian instance, well, I'm not saying the entire Debian instance. This is the bare minimum Debian instance. This is what they've determined is if you take something out, you won't want it. What it does is it keeps it lightweight, and you decide the things that are in your system. How many times, me and Kirk, who were having a discussion today, we have MySQL installed on the system that doesn't use MySQL. Why? Because somebody went and said, pass select link, which installed MySQL on the. A lot of flow that we just don't need. So by starting at the bare minimum, everything you need, you install, you add to it, you set up, and it's the bare minimum to run that specific application. You don't have the bloated overhead of all this other stuff running on your system that you just don't need Windows. So if you're big, not found. Why would that be? Because there's no networking on this particular thing. So it's like, screw it, I don't need it. I don't need it. If you're not going to set up networking, forget it. I'm not going to even bother putting an interface on there. So anything attached to that interface, I don't have to worry. This literally is just a bunch of files sitting on my directory. So if I actually want to do something with networking, I actually have to do some things like add a port to expose to the host so that it then actually sets up. The way it works is you have a Linux container bridge, LX bridge, or the Docker bridge, and it then actually sets up essentially like PPP tunnels into the container. So you'll actually see some different things on the actual host. You'll see a bunch of virtual interfaces, and all that is supplying network traffic to the interface. So, well, we're in a root shell. So let me exit, and so Docker PS, this is just showing me everything that's currently running. As you can see, I have Docker GVL latest running, and you can also see my secret command that I ran. Python 3-m, HTTP subserver on 180. This is pretty simple, but I can also see all the ones that are not currently running, just ones that all have ever run. And so I've got a good many in here, a bunch of them are tests and different things like that, version 12.04, 7, document. You can see at the very top, we have the 7.4. Because I didn't designate a tag Debian, it chose, in this case, this would be the Debian latest, so it chose that one. It goes with whatever's the most current, but it can also designate. So, let me grab this.
It fixes actual nicknames for whatever.
Yeah, if you don't set up a host, if you don't actually designate a host name with the dash capital H, whatever, it actually picks these weird names. And there was a really funny commit about specifically adding names to this. And it was really awesome. This list is 50-50 male and female. And these are all people that have had some influence in technology over the last 100 years. So it's really cool. They actually did a lot of research to come up with some of these things. So kudos Docker, they're probably really bored. I guess so, because you save all this time and spin up commands. Getting to it. So so let's look at the container that I just ran. As you can see, I see that I'm using like the Angular fetch driver. They do have like a Flutter fetch driver and different things like that. These fetch drivers, they do about two. One thing I haven't got to play around with much is the fact that, as I said earlier, that they have gone away from needing links containers. They actually have what's called link container, and it's basically written directly into the kernel. So instead of having this abstraction layer of managing, no, they're going straight to the kernel to have. So they've actually been able to bypass completely LSD if not necessary. So once you get production release, the idea of Linux container and Docker containers has been really become different. Right now they've been kind of synonymous because that's what it was built off of. But you're really starting to see segmentation in that. You can see that I'm not running. You can also see the timestamp of when I started and when I stopped, different things. This stuff can be really, really important. Like all of a sudden an application crashes. One thing very important with Docker, you have to have a comparable process running. The moment it terminates, then it can exit. So you actually, and this can cause some problems right out of the gate when you first starting. One of the easiest workarounds I found is a tool called, that thing. Non-existent. Anyway, it's actually a process manager that actually allows it actually constantly checks for process and stuff. If they died, it automatically starts them back up, so you're able to maintain supervisor D. Supervisor D, really, really cool. It's really awesome if you want to be able to pass in multiple commands. So it's like, one example is James Guardian application that I built. I need to start Swift proxy and James Guardian, so I can only actually pass in a single command argument. So what I did is I set it up in supervisor D for it to manage the process. My command, what's it called? So it's not a native system. It doesn't work exactly like the. Sometimes there is a little bit of trickery you have to do. But understand, it's all for efficiency. So a lot of times, like, why is this not here? There's a very good reason that it's not there. And it's probably because we just don't need it. So let's do Docker commit and commit this container, and we'll call this field. All right, so it spits out this long da-da-da-da. Docker images. Let's scroll up. At the top, I actually have a brand new image that I can use I can then deploy it anywhere I want to. You can use it on your laptop, you can use it out in the cloud, on DigitalOcean, like all the cloud I'm going to do done here. I'm going to play around with them. And so you can actually deploy this anywhere. So it's just as the work. You're familiar, if you're custom to like Git, that's basically how this thing works. You make a change and you have tags, which allows you to actually kind of keep up with the actual versions and stuff like that. It does kind of has its own natural version control system through the layers. In fact, let's see if I go to Docker. I did, right? That don't actually. So this is the entire history of the DGVL application. It started with this container 11 months ago, and then they updated it, and then about a minute ago, I did 14 bytes worth of changes. That's awesome.
Is there any kind of concept or a construct of like consolidating of changes and similar to removal of snapshots in the Veeam environment?
There is a way to actually consolidate, and I don't remember exactly how to do it about it, but the issue that you have to be careful, and it kind of doesn't, it actually will do it kind of itself, because if you go and try to remove the image or snap, or like one of these layers, And if it's in use or a container has used it, it'll say you can't do that. As long as that's free, nothing's relying on that specific set of changes, yeah, you can actually get it. A lot of times the easiest way to do it is to, and we'll look at this here in a second with Dockerfile. Once you have your application built out, like you know how, you can actually script the entire process through a Docker file, which is kind of the configuration and the build file. Think of like essentially a make file. And so the very first thing on that Docker file says from. So you take your base image, whatever it is, build your application on that, and then you only have one step. It's base your application. And that's the easiest way. So you can take all the stuff and manually doing this, figuring out all the layers and all the components and stuff, making all these commits. Once you're done, actually then take the time to actually build out the configuration file, which is really nice because I don't a lot of times want to download a very large container, but if I have a static file that I can actually build it locally, that works. And that way it mitigates a lot of that, all that extraneous stuff. You just have a specific changes you can do.
Yeah, I mean, I think that what you just said addresses what I was asking, because my concern would be over a period of time where you're making changes and updates to the files and libraries and whatnot, you're gonna, since you're doing copy on write, I think you're gonna incur a performance penalty storage-wise because of all that history of changes. So yeah, great.
Yeah, and there is one drawback with the AUFS, and this is part of the reason why they kind of made it switch, or trying to push with Flutter, is it actually has a layer limit.
Oh.
They found out after the fact. And it's really, really high, but there have people that have encountered it. But there are ways to work around that. And it's literally take a step back, build a configuration file based off of a base, or use another one as your base. Because that's one thing, it's like if I use any of these tag images that I've created as my base layer, it wraps all that into one single layer, instead of having all of these different layers as an application. So we've got history, we've done commit. Obviously I can remove containers, I can remove images if I want to, if I don't need them. I'm going to do Dockerfile last. There is the Docker is designed really, really well in a lot of areas. One of the things it allows you to do is volumes. I can do a host volume, so if I've got a file that on my host machine, I can actually have the system basically mount it, and I can mount it as read-only, read-write, however I want to. So that container actually is using the volume that's on the host. I can also do drawing between containers by linking them. So let's say I have an Apache container and have a MySQL container, and so I got my website, and then I got the database on the back end. I can actually link these two containers, and I can link them on any specific port or anything that I want, so that all of that MySQL traffic is just being traversed through that link between those two containers. Docker, one of the engineers, Docker created a tool called Typeworks, and it's this entire, essentially, networking application for all the Docker containers to be able to do some elaborate internal networking stuff, so that you can isolate who can talk to who can do what to whatever. And so there's a lot of really cool stuff. Not only built into Docker, but also built around Docker. There's an entire operating system outside of Mook's Docker dedicated basically to Docker called Core OS. You'll probably hear a lot more about that coming up in the future. So it's not just about what Docker's doing, but it's what is the ecosystem around Docker, the way that people like Red Hat and stuff are joining in. We've kind of solving some of the problems that were inherent, like the UFS layer limit. And we're like, hey, well, Flutter does this a lot better than a bunch of other stuff. Let's kind of migrate in that direction and stuff. So the basic, start, stop of the container is really, really fast. Like, unbelievably fast. I mean, as soon as you hit run, it's like, bam. You have either your prompt or your cat shell and stuff. With a VM, you just can't. Like, you barely, you right click and then, you're just not there. So that's one of the benefits of Docker. Obviously, being able to do the layered system of the layered approach where hey, I've got this really cool container and it does all this awesome stuff. I want that plus this. All I have to do is save that change. That's all I need. And so I'm running one instance. One thing that's really important to understand, like everything that's running Ubuntu on my system and the Docker container, there's one image file for Ubuntu. Everything else is replicated. And it's just layered with one copy. So really, really cool. Let's jump in real quick to
skipping ahead a little bit. With those layers, how does that work? If, let's say after that 10 apps running a server and after we're running a Heartbleed susceptible SSL library app on, is there any way to force them to not use the library that vulnerability, or to easily identify which ones are running
well, specifically your library inside the queue or inside the container, each of those is going to be specifically OpenSSL because it's not included in any of the XP. So you've actually added it to all of those containers yourself. So what you'd actually have to do, my suggestion would honestly be take that base image or that you've got, replace the vulnerable library, obviously do your testing and stuff, commit that as the latest version of that of the whatever application stuff, and then push that out to them. So that's you're not actually having to run any kind of changes or anything like that on the actual system. You actually have to deploy a completely new container. It just has a small modification. And I think that might be the easiest way to handle that. Especially because you have different versions of OpenSSL that are fighting. It sucks. So it's like, hey, these are vulnerable, these are not. All right, we just need to essentially patch them, and by patching them, it's just really convenient.
You still need to run a layer of section that your Docker libraries are being used. If you're keeping some sort of inventory management. Okay, I'm using these things.
Yes, yeah. Anything that you're currently running, like in order to keep up with those processes and libraries and stuff, you're still going to need it. Because it doesn't get away from that. All it does, it's much more consistent, much more viable. All the existing tools and stuff, they still. Docker does not replace anything. Period. Docker, I'm glad you're not listening, will tell you, oh, Docker will get rid of VMs. I can take definitively the point, but we still have bare metal. Until VMs replace bare metal servers, containers can't replace containers. Because they're just new things all over it. And so all of your existing tool chains and stuff like that, you're going to keep those in place. This just makes it a lot simpler. You know, there are some very specialized tools and stuff that can help around. The Docker Greenville is probably a lot easier for you to do with that really cool. Question somebody here?
Yeah, it's actually kind of a simple question. You said like the SSL layer. What if you got into stuff 4, you have 14 more, but you want to do container. Is there a way to change the containers lower layers?
Yeah. Yeah, so what you do is you're running a container. So obviously you've got an image of that container because you don't stuff. You got it in production. You actually have an image that matches that container. So what you do is you take that image, you pull it over, you spin it up, and you attach into it, and then you run your disk upgrade, all that stuff. And then you commit it. So now you've got all that all that stuff that was running on top is still the same. You're just changing the actual, all the internals of that base image. So now what's happening is you've gone away from the default Ubuntu a little bit, and so you've actually modified that entire, you're incorporating that into the entire container.
But that's still layered on top. Because the only
Yes.
containers on
Yes,
top.
it's the change.
So let's say you've done several disk upgrades, so on your stack, you're sitting on a stack.
Well, that's why you actually go to another image at that point. Which you wouldn't do this recursive stacking because there is a tremendous amount of cost at that point, specifically with Docker Greenville stuff. But yeah, so like if you wanted to actually do Like, you got a 1204, you want to go to 1404, but leave everything else. I mean, the only thing that you're actually able to leave is your actual application for your service. Because in that disk upgrade, everything changes. So you're better off, in all honesty, actually taking a 1404 image and dropping your app in there to SC.
I think that part of the solution might be a segue to the next thing we're going to talk about. You build a Dockerfile, then you have an automated way to build up an image. And so it basically just scripts, and you can just specify your base, and then go step by step.
Yeah.
So then, you can start wherever you want and have a replicable way to provide it.
It's more like configuration management.
Yes, yes, and that's one thing. Chef, Puppet, all these tools play very nice with Docker. A lot of people try to do these comparisons. It's like, oh, Docker is, it's trying to replace. No, it's not actually. Docker is designed to containerize, protect the code. The configurations and all that stuff, you still use your favorite tools, Chef, Puppet, Vagrant, is a very popular one. All these things interrupt because Docker's not designed to replace something. It's designed to do everything more efficient. So if I can have the isolation, the protection and security of the container, and configuration, management and stuff with Chef, that's a home run. Or Puppet, or whatever, whatever your solution you're doing, like continuous integration with like Travis and non-existent with Beacon and stuff like that. It's not replacing any of those tools. You're just adding something into that equation to make things more repeatable. But good question. All right, I'm going to open up Dockerfile. Alright, I don't actually have so critical it's never done. Alright, you can see that? Alright. So the Dockerfile is simply the configuration in which to build an image. And then from images, you deploy containers. Okay? So in order, like the base with a Dockerfile is you start with from. Where's our origin? Where do we go? It's going to be Debian, it's going to be JBoss, it's going to be to. So from we're going to add a maintainer, which is going to be me, you can get an email address, stuff like that. And so and then you start this beautiful thing called run. Run is exactly what it sounds like. It's run this, run that, run so sudo update. That's a run. So I can run sudo update, sudo upgrade, sudo install Apache 2, sudo install blah 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 blah, whatever and so on and so on. Each one of these is a run key. And so if you're familiar with Bash, then it's just Bash syntax, essentially. So it's just run and command, run and command, run and command. But one thing to understand is it is highly advantageous oftentimes to combine your run statements. So if you can do like sudo update, ampersand, and sudo upgrade, and the reason why you want to do that is every single line of this Dockerfile that's in a run is its own line. Or essentially its own key. So what happens is it goes to do this, writes out the layer, takes the next chain, writes out the layer. So if you've got this really, really expensive Dockerfile, you you could be talking thousands and thousands of layers just to generate your application. So what you can do is a lot of times you can actually condense them into a little bit more manageable. And what I like to do is I actually like the update, upgrade. I like to keep that in one, and then my actual, where I'm installing services, applications, stuff like that. That would be another one. Let me actually go put this on. Alright, so what we've got here, this is an example of the Dockerfile. So we've got from Ubuntu, and this is the typical toggle folder. In this case, they didn't pay to maintain it, you don't have to. But if you want credit for what your awesome work, go ahead and add maintain it. So you can see here we're doing run apt-get update and run apt-get install. And that's why Apache 2. If you're in the Ubuntu world, -y, -s, assume -yes is very, very important. You have to put this stuff or the build will actually fail automatically. So all we're doing is setting up a simple Apache server. And then I'm able to actually pass in environmentals. So I've got env Apache for one user as wws/data. Same thing for one group. I set the log directory as var//log/log/10. I'm exposing port 80. This is a very important step. Expose 80. What that's saying is I need whatever IP address you assign to me, to this container that's running this, I need you to expose port 80 on that on the host so that I can actually get to it. And then the entry point, this is the point in which when you run the container, it starts, it goes to /user/s/apache2, and the command that it's actually passing is -d for naming and running it in the foreground. We want it to run in the foreground so the process doesn't make sense. And that's the basic. Now, there's obviously a lot more that you can do with Dockerfile. You have things like add, which is really, really valuable. So if I've got an existing library for application that I've already built, let's say like a Node.js app or something, so I've got this folder called app, I can actually take add app to /where. And so part of that process is it actually adds a copy into that image. And so this is, you can also, this is where you can actually declare volumes and stuff if you've got many containers, as well as you can also do it in the actual command line office. So let me save this right quick. Dockerfile. So it's going to be Docker build -t, and this is for the tag. You have to do the tag. And so in this case, we're going to here. So I've got a Dockerfile. The Dockerfile is in this my current working directory. That's one thing you actually have to do with the Docker build for. You have to actually pass it the whole path. Either way, most of them I can do it directly in the construction. So we're going to build. We download it. All right. So now I'm getting rebuild. It's actually, because this is based off of the roots and stuff, it's really more context. Everything that you can try to need. See how long it takes. Really bad. You know what you know why it's going on.
I have to get back to that.
Yeah. So the nice thing is we can cancel that really, really quickly. So let's go see. All right, so here we got the Dockerfile. All right, so this is the actual Dockerfile from the presentation. So from Ubuntu latest, run apt-get update assume yes, install Python 3, assume add presentation. If you look right up here, so I've actually got the presentation folder. It actually contains the presentation. And so it's going to add it to the Slack presentation. I've asked it to expose port 8080 to 8080 on the host. So what's cool about here, go to like 172.17.0.2 for 8080, or I can go to whatever the IP address of my host is. I can get to it either way. So the work directory that I want to do on my work is Slack presentation. And the command that I want to run there is Python 3-m http.server on port 80. And so if we actually do a Docker build on this, and we'll fly by. As you can see, it's actually each of these right here, these are layers. So, and they correspond with each step. So, I set the work directory. This is essentially equivalent to CD / presentation. Setting the exposed port, this is actually running that. Basically, it's an IP table. It's the equivalent of what this is. And so every time we're running one of these calls within the Dockerfile, it's actually writing a brand new layer for it. And the result is I've successfully built this image file. This is the image ID. And so through the screen, Docker images, and it goes all the way to the top. You can see that I created name 47 seconds ago, and there it is. And so it's 253.3 megabytes. That's the entire thing, including the base image, which is not too bad. Because for one thing that this doesn't, the virtual size is it doesn't actually tell you the actual size of the container, because that's including the base image as well. So the workloads that are actually give you the actual the amount of the size that you don't. But my changes are very minimal. All I did was make it a batch history. If you don't understand batch history, adds up really, really fast in terms of height. In every single one of these, actually results in batch history. So you're writing all these bytes all the time and stuff like that. So that's basically Docker in a nutshell. You get a lot more depth to it, especially when you start running services, you start running multiple applications and things like that, self-aware systems, service discovery, things like that, like the PD and stuff. It gets really complicated, but it's really, really impressive. So I encourage you guys to go check this out. You can try it out on your laptops. If you're a Windows guy, you have to run the VM or use DigitalOcean. Apple, on Mac, you actually have a way to install Docker natively, as well as Linux, Red Hat, Fedora, all that stuff. Ubuntu, You can run it. Docker.io is the website. The documentation is world class. I can't think of a time that I've had an issue or a question that haven't been able to find in the documentation. The Docker API, they have a remote API, is phenomenal. You can be able to call it over socket or over a TCP port. So if you want to do remote management of Docker clusters, you can do that. Lots and lots of stuff. It's not just about the individual systems. Docker scales unbelievably well. So that's Docker. Any questions? All right, what's up?
So for that networking bridge layer that you're talking about, do you have any kind of concept of multi-tenancy whereby I could say, I want this cluster of containers here to have these IP addresses, and then maybe using some kind of network isolation have a similar cluster like a dev or test environment have the same IPs but not interact with it?
Not specifically in Docker. Docker doesn't think that solution, it works very, very, very well with something called Open vSwitch.
Yeah.
Which is actually designed to replace Linux bridging.
Right.
I'll go ahead and answer your question, Shay. He sent an email to the company with Open vSwitch, pros, cons, and stuff like that. One of the biggest pros is speed. Compared to Linux bridge, which is default ability in the kernel, it's about 6 times faster per CPU gigahertz than bridging. You can do things, especially internally with Docker. Well, that's one of the things where I said that there's a little bit of network disadvantage. Open vSwitch mitigates almost all of that and then some, because you're actually, especially if you're doing networking between containers, it is unbelievably fast. Now, obviously, if you know anything about Open vSwitch, it's classified as an SDN system, so certified network system. It actually has a controller system. It uses flows, which is a little bit different. But yeah, that's the easiest way to do it. And there's a great tutorial on actually doing not only multi-tenancy, but multi-cluster Docker installation. So basically, it's basically a series of these V-labels separated on the coverage. So really, really cool stuff. And it's a really nice way to be able to land on being all these Docker images and stuff and all, and you can this just within this network segmentation. And I mean, these here, maybe on the same code, it's not a problem. Because you actually, in your, /etc/default/Docker, you can actually designate what bridge to use for your containers, and you can have multiple instances of the Docker things running. So you would actually have one for, bridge 0, one running for bridge 1, and bridge 1, 0, maybe have some, communication stuff going on stuff. You get into a really, really, where I like to play on the software-defined network, you draw it up and you make it.
Cool. Thank you.
Any other questions?
But it's still not clear if you need to distribute your application to specific client files. And it's based on based on that and the other layer. You have to distribute those files as well. So you
Yes. Yes. So like if you pull, like if I send it, if I create an image, an application, send it to the registry, and then you go Docker pull, or what's even better, if you just go Docker run, send an application, it doesn't exist on your system, so it's actually going to automatically pull that from the registry. It's going to download all the necessary layers to do that.
So there are the tools for installing your own registry and so on.
Oh yeah, that's Docker's guide. The funny thing about it, Docker registry runs with Docker. Yeah, you actually can use containers to manage. But yes, all that stuff is readily available. They also have private repositories on the index now, like GitHub does. I think it's something like $7 a month. But what I would encourage you to do is actually just go look up Docker private registry. There's plenty of information. There's literally, in fact, let me see if I can. but I'm pretty sure it's a basic one. Docker search. I'm the world's worst. As you can see. It makes you fall. So yeah. So these are, this is actually searching the Docker index for anything that's registry, and these are all different versions of registry systems that people have made themselves. I think if I scroll up, I can actually find the Dockerfile or the activity. That's not a Docker. This one right here, Shipyard Dockerfile registry. That's the one you want to go with, hands down. If you go to the index, docker.io, just do a search for Shipyard. The work they've done is amazing. They actually have a tool called Shipyard. They got real creative with that, and it is actually it's actually 5 different Docker containers running all together, kind of as a service or system as a service kind of thing, and it actually allows you to manage remote Docker codes. So I can go like, hey, I can see all my images, I can see all my containers. I actually can deploy them and designate which hosts they go. Shipyard is actually it's just one guy. They picked that name and stuff, but they've done a lot of really cool stuff. If you want to hit the ground running with Docker and see what it's really capable of, Shipyard is one of my favorites. Also, there's a program or an application called GitLab. It's designed to be an Python notebook and Unix notebook testing environment or learning tool. And so basically what it is, you go to the web page, you sign up, or you put your username and password, and then logs you into your own Docker container that has your Python notebook. You actually learn Python stuff, and then you exit out, it closes the container, and everybody who goes to business with website actually gets the old container. Really intuitive, and really ingenious system because there's not much space and stuff. He doesn't even have a database outside of the actual Docker system because it manages all that stuff for him. So he has a Redis server that he can. Yes.
So if you were wanting to test, say, 2 Docker containers, one was a web server and one was a client, and you wanted to get one talking to the other, would you have to expose port 8080 on both of them?
You can link in the run command. So you'd be like Docker run in your arguments. You actually can do a link, and so you just so it'd be like link. Let's say you gave it a host name of like web server or whatever, something like that. Link that, and so when you spin up the web server, give it the link, and you give it its ID itself, and then when you spin up the client or whatever else, you then link back in the web server, and then those two can talk directly to each other. But anything outside the system, so if you spin up a third one without linking them, it's not self-contained. And one thing that's interesting, let's see if I don't know if it still has. All right, so we got that's fine. But one of the things that you can do if you with Docker, obviously every container has its own process tree. But understand the host come with man units, so they also show up in a host from our process 2 as well. So if you're just working on the host, you can still process. So like if I go with build Python, with some server, it actually will be our container client because the container requires a process to be running. As soon as that process terminates, it exits, it's done. So not only do you see processes like you can talk from the outside of the container, you can actually just, whatever you're doing on your host, you can continue to do that way. So, lots of little tricks and stuff that you can do. There's very little that I have wanted to do with Docker containers that haven't been. The biggest thing is understanding it is not a default. The default latest does not have a lot of things to find in your system. Okay? Not to get in a editor war, that's what Linux people love to do. You know, we're all going on Notepad and Wine. Nano. Well, hey, it's not in there by now. It's like, you don't need it. Buy is in there by default. So it's literally, you get this bare minimum, and whatever you need, you can build it. Also, a new tool that just came out like 3 weeks ago, I haven't got to play around with it, but Docker guys are flipping out over it. It's called auto commit. What it does is, so if I do an interactive shell, so I'm in this interactive shell right now, and so I can see that you know, I'm at root stuff. So if I started building an application or started adding files and pseudo apt-get and stuff like this, all the stuff, because let's say I don't know all the components, the dependencies and things like that are necessary to build a Dockerfile. You take and do all your process inside the container, you build it out, you commit it to an image, and then you run auto commit on that image, and it actually exports the Dockerfile. So everything you run on the command line, it actually then exports out to the Dockerfile so that you can ship that to whoever. Instead of having to ship that image. And there are some advantages to shipping just a static file, especially with a lot of the registries and stuff are private, but they've got a copy over here. There's no sense in going like, here's this huge massive image that I put over here. No, it's just faster to download it locally than across the internet stuff. So you send a file, they do Docker build, give it a name, tag it, and run. And so then they build their image of that file instead of having to actually download the other file to actually do something. So, like I said, it's really, really cool, really, really innovative. So now that we've had a kind of introduction to what Docker actually is, next time is just communication and why we actually have Docker people. Now we're going to do something. Like, it's awesome just to have this kind of, like, all this good stuff. But there's a lot of things to do. And I personally think to work with Wryen for the Code Brigade, because this is the technology that can really be utilized, especially if we get developers and stuff coming in from different areas, different expertise and stuff. And we got a reliable way that we can afford them. And thanks to DigitalOcean, we got 5 months free to do it and stuff. So, there's a lot of stuff that I am going to be scheduling a regular Docker Greenville meetup. We're going to go more in depth, specifically with like services and stuff, how to lease containers and stuff like that. But also where we can get involved in actually building something out, where we can actually do it ourselves, kind of interactive labs and stuff. So I do encourage you guys to go get these before you leave. But go home, play with it. Play with it at work. You'll find a reason to use it. Like, I mean, it's not hard. My coworker Kurt, he's using Docker to build tomato firmware for MIPS routers, where we've got a bunch of different modules. Well, he has a bunch of different container, one for each model, and they can build it concurrently.
Yeah, I mean, the thing is like when you're developing software, like, of course you have this source package, and you know, if it's not, you know, you might need like part of this needs that one particular version of element, and you know, you want to run by the latest before, it doesn't happen. So I can just put up a whole venue or whatever, and make sure that I have the entire building environment that's already set up. So I have all the libraries and all of the build tools that need to build that, and I can easily automate that entire process. So just kind of type of command and off it goes, and just returns, and it's all done. But I think for like me, like learning Docker and stuff is interesting. Like the paradigm is the container code blank wait. You can do it lots of different ways. And the paradigm is kind of be one application per container. And so, you know, you're going to run your database and your web server on different containers. You're hooking them up together through internal networking or shared processing volume or all those different ways to have them talk together to communicate. So running one VM with your database and web server on. Because the hardest thing is like that last command that has it is basically your init. So you're not understanding your init process. Just upstart and system so you know, there's different ways to close supervisor D or shell scripts, but we're basically just running one process and then waiting for it to finish. But yeah, I find lots of users for it all the time.
But if you can't find it, you just come back and tell me what you do, we'll find it. Like, so let's see. I mean, any mind, like, I know we're a little bit older generation stuff, any Minecraft fans, players, okay? People like a ton of Minecraft servers, and Dockerfile or whatever, and all these instances and stuff, and do some really cool networking, and then you can have your entire cluster of Minecraft servers and they're hosted, and then that's they probably put it off, but you can do that. And stuff, you know, little things like one of the things I'm working on now is actually we're kind of in this kind of home automation, but with really good grades and stuff. So I've got a home automation that actually deploys really easily. So with basically, you know, conceptually like a click of a button, you have this home automation stuff. Things that lightweight services, the things that sometimes really difficult and complex to set up. Anybody's familiar with script boxes. I love script boxes. One of my favorite tools. If you see the configuration file, the first thing I do is delete it. And I apply my own. Like I trim everything out that I don't need because I don't know what half of it does and stuff like that. So trying to push through something really different. But if it's like, hey, I need a script proxy on my network, all right, cool, no problem. You know, Docker, Wryen, -d, becomes squid. All right, cool. And then you just set up routing table rules to actually route all the traffic through that container. Awesome. So it's a lot of little things that we're looking for, like, hey, I really want to do this. You can do that. You don't have to have these things full.
I have two quick questions. So the public repositories that you talked about, it seemed to me that since you used the analogy of GitHub, how it's like the GitHub of repositories, would you not also then have the same security concerns so that you shouldn't just go and download and use anybody's old container because you don't know what in the world it may be doing?
Okay, that's a very good question. And part of the answer to that question is GitHub. Docker uses what's called trusted builds.
Okay.
And the way that works, in order to get a trusted build, the code has to be published on GitHub. They actually make that into to your end and stuff. And they actually go and do a code review to actually put the trusted seal on there.
Gotcha.
So you have trusted builds, whether it's Docker or and then you just have everybody else. And it does, you use either one or your own. Mostly I stick with trusted builds because that gives me the ability to not only, I can do this really fast, but while it's actually downloading and pulling, I'm actually on GitHub looking over the project, looking at stuff, seeing if anything looks really weird. So they do address that concern through GitHub. But yeah, you should be careful to a degree because you never know what somebody's code's doing. The good thing is, to date, there has not been a documented case where something malicious in a container has been able to leak over into another container.
Sure.
Now there is potential for post-execution maintenance and stuff, but there hasn't been a use case that's been presented that actually says this is how you do it. Stuff. It's all kind of hypothetical stuff. But yeah, like anything, trust your sources. If you've got to know where your sources come from. If you can't look at the code, I don't suggest it. Honestly, I don't suggest it. If you can't figure it out yourself, and you have to, then that's fine. But most of the time, you're like, all right, if it's on the registry, you can probably figure it out. I mean, let's say you're a Fedora guy. How do I install this on Fedora? Guess what? Follow those instructions. So go Docker Run -I-t Fedora /bin/bash. Follow all those instructions to T, commit it. Now you have a container.
And finally, real quick, so you talked a lot about performance comparisons to a Type-2 hypervisor. But, one of the things that's the advantage of a Type-1 hypervisor like VMware is the transparent page sharing. And I presume that since this is just using whatever the kernel's memory management does, that it's not going to do any kind of TPS. It's just whatever the kernel has.
Not going to matter.
Okay, just curious. Thank you very much.
Is anybody going to use this or at least try it?
Mm-hmm. Yeah.
All right, cool. Like seriously, like I said, Tim Fowler, you can find me on Twitter, you can Facebook, LinkedIn, whatever. I'll answer any questions that you've got. I'm not an expert in this by any means at all. I just really love it. It's amazing the things that I have been able to do with it. Stuff I'm just like, wow, that's like the slash spin up an entire /24 web servers. It's everything that. That's just freaking awesome. Like I haven't even figured out which ISO I'm going to start, and I've already got the entire thing set up stuff. So, like anything, there's going to be some growing things. There's going to be some difficult stuff. Use wisely. When you get it sorted. Look at and it's fine with the limitations of Docker. I've actually learned a lot about processing and different stuff. Some of the guys using Docker. I'm like, well, it used to work this way. Yeah. When I have a full-blown server architecture and all this stuff, I don't have that. It's bare minimum. Don't worry, there's actually Docker images that are more like a native site. They're like, they one process, built it out. They added all the stuff. And then I've seen people, there's actually a company in California that's actually, they went away from terminal services, and they're actually running desktop through Docker with exporting. I'm like, what the heck? So they got these like really dumb terminals. And they're this giant cluster running all the desktop because everything they do is web centric. Like, hey, more power to you. So, do you have a question? I saw your blue button.
The digital ocean, there is, you were talking earlier about performance
Yes, yeah, absolutely.
Is it practical for production, or is that more like you want to play around?
Me personally, I would say just kind of for the playground. Depending on what your system that is going to be, you could easily, like, I was going to, let's say I was going to spin up like 5 or 6 VPN servers with unique configurations all on the host. I do that on the solution all day long, no problem. But but if I was doing something production business, I would look more towards actual bare metal, dedicated service, stuff like that. Because I understand you are going to have a performance loss because you're immediately on your in a kind of the DigitalOcean VPN, I believe. You already have that loss, but the cost is $5 a month. So it really just depends on what you need. But if you're doing something speaking heavy production, I would recommend trying to get something a little more bare metal than you did like playing around, just having fun, hacking stuff out. For trying new operating systems, new server issues and stuff, Yeah, it's fun.
That's the main point, but a lot of this stuff up in the now is literally over on.
Yeah. Yeah.
It seems like a little less practice. That we can get down software, the Linux level with the
Agreed. Yeah. Yeah. And that's why I would, it's like being on stuff like that. They're not going like, this is a specific instance, specific use case. You're always going to be able to find someone why this is a horrible idea. So it's about being intelligent. It's about using the best tools that come. And Docker can be the best tool for a lot of jobs, but it's not the end all be all. There are times that I would be like, I'm not going to waste my time with Docker because some restraint or something like that or whatever. And so, yeah, it's not an end all be all. But yeah, if you were like where your money and everything basically, you want to think and stuff, if there ever came a point where you needed to a little bit more isolation, say from your database and stuff, all of that, then you probably look at that, but I'd also probably upgrade my instance, get a little more CPU, a little more memory to do so, just in case you have to look at if you already need a little bit. But understand, as far as CPU and the memory, it's basically about bare metal. So from the digital ocean, whatever that barrier could be, basically, obviously the smoke, and especially more in your case, like you've got your web front end, your database, and all this other stuff. Your biggest impact is going to be network output. You would have to put that in a definitive walls out of the box. So you would probably have to switch to something like OpenV switch to compensate that, especially if you start isolating all these things these pieces, containers, because you've obviously got a lot more directed network traffic. You really, what you're paying for is the direct. Hey, you go here, you go there, you go that stuff. And that's stuff unfortunately. So it's like, it's nothing I'll be all, it's pretty darn good. Guys, I do appreciate you spending so much time with me.
Are you going to be giving this one next month?
I am going to be giving the talk myself. Yes, I am, and you are too. I noticed that. Congratulations. Yes, I am going to be doing a Docker talk at SouthEast Linuxfest. Unfortunately, it is going to be very, very 45,000 foot view. Just due to time constraints, people a lot. Although I do have something in the works, just to go, and then I'm going to be, asking for more stuff. So there will be a kind of continuation of the class of this talk. We plan to have regular Docker meetups. One of the things that I want to get as a collective group, I want us to get in and working in our own technologies and stuff and actually developing really cool applications and systems and services and stuff. So there will be probably some hackathons. I'm probably going to try to piggyback off the code for Greenville, because why not? It's hard to only one event, so it's got 22 events. It's chaotic. And the beautiful thing for me is, if you remember, like forever ago, I asked how many Java, PHP, Python stuff. We have such a diverse group. But every single one of us can deploy applications in this manner. So it's like, if you bring something that they did, I can get it out there. And so this is going to, I kind of wish Wryen had been able to stay around for this. And kind of see, because this is one of those things that when we can do, so we got some really killer job guys that do really, really awesome stuff. And I was like, hey, you got this application. Cool, don't worry. I'll get it deployed, I'll get it where it's managed, everything like that. We'll worry about the operations and stuff. So that's what it's at, man. It's Red Hat has made a huge investment in this. Red Hat Summit happened about 2 weeks ago. 80% of the talk was Docker. In fact, George Wall, who's here, he got sent me a message and said, this is all anybody's talking about. This is a really big deal from an infrastructure standpoint. If you really want to have some fun, take Docker and install Open Vswitch on top of it, and then you have a data center in the box. I kid you not. Full data center in whatever you're carrying around with you. The capability to be able to set up potentially hundreds of machines, set up complex networking configurations, policies and stuff on the laptop. Very, very cool. Very, very powerful stuff. Great reputation stuff. I've got some t-shirts. Oh, last question. Is anybody interested in BSides Asheville Security Conference? I forgot I've got a ticket to give away. June 7th. It's a Saturday, 2 weeks before 7th. All right. So they're going to be really disappointed that I couldn't give something for free. But anyway, I've got some t-shirts that are medium large, extra large. Sorry to call it something. I had to beg and plead to get a Fat Man Premium shirt, and that's what I asked them. So if you want some, there's some over here. First come, first serve. I do want to say one for the Iron Yard people. They're awesome. Thank you so much for hosting us. Supply Technology. First ever they pay for the food. Obviously, Docker helps sponsor this, as well as DigitalOcean stepping up really, really big. If you are on Twitter, please go say thank you to both Docker and DigitalOcean for helping put on this event, because if it wasn't for companies like that, then it's not going to so come get your $25 credit. I'm telling you, use it. You'll have some fun, set up a VPN server, do something stupid, because, whatever. Not too stupid. Yeah. So please come get one of those. If you have any questions, I'll hang around for a few minutes. I will be on. I'm on IRC a good bit. I'm in the Greenville channel on Freenode, as well as the Docker channel. If you ever need anything, go to Docker on Freenode. Any question is awesome, because you sit here and ask some questions, and all of a sudden the CTO and founder answers the question. Chief engineer, who just got through done doing a presentation on Switzerland. Who's your answer? Really, really cool. If you want to look at a model of an open source project, this is the one. I promise you. The thing that they have done, the way they've reached out, I contacted them, like, hey, this would be cool, there's no Docker instance, nobody knows about Docker hardware, they're like, we'll give you everything you need, you're in charge. Okay. Like 2 weeks later, here's a bunch of t-shirts, here's a bunch of documentation, like, all right, next thing I know, I see it's going out on their newsletter, like Docker Greenville and stuff. I'm like, crap, but they really put the power in the people's hands to help communicate and change lives. So I've had fun. I've talked a lot. I'm sorry. If you have any questions, please answer. If I did a really horrible job, don't tell me. No, dude. Sorry for the battery going dead and everything else. It's been a long week, probably every time. But other than that, we're done.